Hello, everyone. Once more, it's me, Dr. Agu Collins Agu. I'm with the Startups in TD for Power IoT Hub. Well, I've just mentored them, took them through how to apply the Unity board for smart agriculture. So, first of all, we'd like you to have a general overview of the setting here. And what is interesting today is that we have some soil sample. Over here, I have, as you can see, I have a very wet soil here, very, very wet. And there's a thermometer there. This is a wet soil, you can see it. It's to measure the temperature of this wet soil over here. And then here we have dry soil, you can see. So this is a probe that we measure the soil moisture, and here is the soil that is a bit damp. So we'll be comparing the moisture content of this jar with the moisture content of this very one. Okay, and then over here we have our sensor that measures humidity of the air. So this is over here. This measures the humidity of the air. Then here is also another thermometer that measures the temperature of the air. And here is our gas sensor. It measures LPG, it measures carbon dioxide, and also dust or smoke. Over here we have another sensor. It measures the intensity of light, the ambient light. One interesting thing about this very sensor is that it breaks light down to the components of red, green, blue. Very, very interesting. And then over here, we have our display, LCD display. And I would like to also mention to you that all the data that is being measured here is also streamed to a cloud application for data analytics. This is the first level of the design. So the first level here is we're basically acquiring data. That's the data acquisition phase. That's exactly what we're doing right now. Now, a closer look to this very display. We have the moisture of the soil to be 6%, air temperature 28.87, and so on and so forth. I mean, it's so accurate that if you have a look at the temperature here from Google, I'll get it close. You can see that the temperature we have here is 27 degrees centigrade, and then the humidity here is 81%. So let's see what our device is giving us here. So our humidity here is 78%, and not too bad. Of course, the Google has not updated for some time. So now the moisture of the soil is 4%. So let's see what happens if I transfer the probe that measures, the sensor that measures moisture to a different soil with higher moisture content. Let's see what happens, what reading we get here. So let's have a look. See, the moisture is already 77%. That's risen. And again, let's see what happens. This is spray. So I will spray this onto the gas sensor, and then let's see what happens, what display it will show. So I sprayed it now, so let's go and see what it gives us here. So you can see basically it has increased. It's giving us readings of CO2 and so on and so forth. So this is a use case of Unity board, IoT, AI STEAM education. It could be applied in various areas for smart technology. So here we're basically demonstrating a smart agriculture. So with this very device, or with this very setup, you can actually have a remote farm environment monitoring system set up where you could actually know how your farm is doing. And you can actually know when your crops are growing because the light sensor breaks it down to the components of light, red, green, blue. So you have more green coming out, that means your crops are growing. Or maybe your fruits, maybe apple. If it turns more red, that means you can actually harvest it. So this can be extended, to other areas in agriculture. So you see the same Unity board, just as mentioned previously. Areas of applications are very, very vast. And one more to remind you all, this is a board that was championed by the Honorable Minister of Communications and Digital Economy, Dr. Isa Ali Ibrahim. So this is local content at work, and this creates an avenue for technical mentorship and also for technology transfer. So this is the first stage. The second stage now will be the cloud application, where we stream the data to the cloud, do analytics. And then with AI, we could do various predictions, and that could actually help improve food yield, especially if we consider some of the climate changes, which is a challenge. This will actually help us in agriculture to improve food productivity and also food security. Thank you once more. I'm Dr. Agu Collins Agu, a director in NIDA. Bye.